Hi guys, welcome back to another video. So in this video, we'll be solving this problem number of k divisible pairs. It's a medium level problem. So let's see the problem statement. You're given a list of integers, nums and integer k. Return the number of pairs I is less than j, okay, such that nums of I plus nums of j mod k is equals to 0. So the sum of the elements of that pair should be divisible by k. Okay, so let's see the sample input. We're given this array 2, 4, 5, 1, 2 and k is 6. So we got the output 3 and the pairs are 2, comma 4, okay, 4, comma 2 and 5, comma 1. Okay. Okay, so let's see how we can solve this. So we are given this array and k is 6. So the first method in which we can solve this is we can check every pair whether it's divisible by k or not. We can check every pair, and if the sum of the numbers of that pair is divisible by k, then we can increment our answer. So we can just check this simply by applying two loops in which I first will be fixed here and will traverse j from this here to here, and then I will fix here and we will check j every element from here, then here to here. So this is a simple brute force method in which we have to check every pair, and we can just check by applying two loops. So the time complexity of this will be O of n square, where and as n is of the order 10 to the power 5, so it will definitely exceed the time. So a better way in which we can solve this is we can use hash map. We can use hash map in this problem. Let's see how we can use map to solve this in more efficient way. So suppose a sample is this. Let's take another sample. So suppose this is our array, and in this array there are three pairs. First is 2 comma 10 and k is 6. So 2 plus 10 is 12, which is divisible by k, which is 6, and another pair is 10 comma 8 and another pair is 11 comma 1. So these are the three pairs. So answer in this is 3. These are the three pairs which is divisible by k. The sum of the numbers in the pair is divisible by k. So what we can do, we will first the first step is the first step is what we'll do, we will traverse through this array and we will replace every element with the mod k. Like if here, like for the first element 2 is present, so we'll replace it with 2 mod k, which is 2 mod 6. So it will remain 2 only. 2 mod 6 will be 2 only. Then at this we will replace this with 10 mod k, and 10 mod 6 is 4, so we'll replace it with 4. Then 11 mod k, 11 mod 6 will be 5, I guess. Yes. 1 mod k will be 1 only, and 8 mod k will be 2. 8 mod 6 is 2. So our array now changes to this only 2, 4, 5, 1, 2. And after that, we can check that the sum we have to check the sum of two numbers is k or not. We just have to check if the sum of numbers is k or not, because we have already taken the mod of k, so every number is now less than k. So just we have to check if the sum of two numbers is equals to k or not. So this problem reduces to this, where we have to check every pair, and we have to check if any pair sums up to k or not, because we have taken the mod and every number is now less than k. So so what we can do, we will first create a map. Let's create our map. So this is our map, and now we have to check the number of pairs which sums up to k. So what we'll do, we will apply a loop like this for int I is equals to 0, I is less than n, p plus plus, and if so Inside that, what we'll do, we'll check if MP of k minus this element, which is nums of I, is present or not. If it's present, then we have to increment our answer to how many pairs of this are present. So, and we will just increment this in our map, its value. So let's dry run this like what we are doing exactly. So suppose our I is here at the 2. Suppose our I is here. So what we'll do, first we'll check if there any element which is k minus this number. So k minus this number is 6 minus 2 is equals to 4. Like we already have encountered this number at the past, like in the previous element. If if we have encountered this number or not. If we have encountered that, then it means that it is already in our present. Then we have to add the answer with number with the frequency of this number. Like if 4 is present two times, then there will be two pairs, like 4 2 first 4 with this 2 and second 4 with this 2. So if this is not present, just we got to know that this number is not there with that, which will sum up to k. So will then after that we will not add anything to our answer, and just we will store this 2 and increment. Initially it was 0, so increment its value to 1, and then we will move our I, and then we will check if k minus, so 6 minus 4 which is 2 is present or not in our map. Yes, and yes, it's present. We got 2 in the previous element, and so it's present in our map. So what we'll do, we'll just increment our answer to the frequency of the 2 which is present in. So the value of this is 1, so our answer will go from 0 to 1. So answer will increment to 1, and then we will store 4 here the map, and initially it will be stored as 1, value will be 1, and we will increment our answer. We will increment our I. Now we will similarly check if 6 minus 5 equals 1. We already have encountered 1 in or not previously, and it is stored in the map or not. So it's not there. So we'll just do 5 and 1. We'll store 5. Then we will come here. Then we'll check if 6 minus 1 equals to 5 is present or not. So it's already present. So we'll increment our answer to the frequency of 5 in our map. So it is 1 right now. So 1 plus 1, which is 2. So answer will increment 2, and we'll store 1 with value 1, and then we'll check, and then our I will come here. So again it's 2, so 6 minus 2 equals to 4. So yes, 4 is present in our map, so I increment answer with the frequency of 4, so which is 1. So 2 plus 1 equals to 3, so our answer will go to 3, and then we will increment 2 from 1. It's already present in our map, so its value will increment from 1 to 2, and so at the end we will return our answer. So this is the way in which we can use map to count the pairs. And yes, there is an edge case. Suppose there is an element in our arrays, like suppose k is 5, and suppose these are some of the elements. 5 1. So k is 5. So after taking the mod, it will reduce to this. Okay, so there are two zeros present. So let's take another map here. Oops. Yeah, so this is a map, and we will similarly do the same procedure. First we'll see 0, and in this, what is the edge case is, like if 0 is present, so we know that 0, it came from the element which is already was divisible by k. So if we check this, like k minus this number 0, we will never get 5. We will never get 5 because after taking the mod with k, there will be no element which will be equals to k, right? So we will never get this 5 in our array. But suppose there are two zeros, so this 0 means that this earlier there was a number which was divisible by k, and also here, so the sum of these is also divisible by k. sum of these is also divisible by k. So how we can do, if there's 0 present, then we don't have to check this 5 minus like k minus. We just have to check if there another 0 present or not. Like we are here, suppose. So there's no 0 present initially, so we'll increment to 1. Then similarly for 1, we will check if 4 is present or not. 5 minus 1 is just 4. So it's not present. So we'll not increment our answer and just we will store this. And 4 is, so 5 minus 4 equals to 1. So I increment our answer to 1 because here 1 is present. So I will store 4 here. And if we got another 0, so we don't have to check k minus 0. We just have to check if there's another 0 present or not previously. So there was a 0 present, so we'll increment our answer to the frequency of the zeros present earlier, so it's 2. So answer will be 2. Our answer will increment to 2, and we'll then store again 0 from 1 to 2, and this will be, so at the end we'll get answer which is equals to 2. So this was the edge case in this problem. So the time complexity of this is of n, because we are just storing the values in the hash map, and it takes off one time to check whether an element is present or not in the hash map. So time complexity will be O of n, and in this space will also be O of n. Okay, so let's go put the solutions. So first we will store the size of the array in a variable n. And for the first method, what we have to do, we will apply two loops to check every pair. Oops. And initially our answer will be 0. And if nums of I plus nums of j will be inside the bracket, mod k is equals to 0, then we will increment our answer and we will return answer. And if, let's take case n is equals to, oh, I don't think it's necessary, so let's run this. So we got accepted, but it's just a small array. So but after submitting, most probably it will give us time limit exceeded. And yeah, for this big array we got time limit exceeded. So let's comment this. So int n equals to, then do again, and we'll now make a map which will be just unordered map. Like we don't need any ordering in our map, like it should be sorted out. We just have to check if that element is present or not. So we just make an unordered map. And first of all, what we'll do, we will replace our nums of I will be nums of I mod k, and after we will first check if mp of nums of I nums of mp k minus nums of I is present or not. So mp dot find, it will be like this, not equals to, if it's not equals to mp, that like if we got that element in a map, so we will increment our answer plus equals to that frequency, like the value. So it will be k minus nums of I. So at the after that we will just increment this value in a map to store this value in a map and increment its value. And let's take our edge case. If nums of I equals to 0, then we have to just check if that element, so we'll just increment, like if it's present then it will if nums of I equals to 0. Okay, so answer plus equals to mp of 0, right? So after that we'll return our answer. So let's run this. So we got accepted, let's submit. And yeah, we got the success, and code took only 70 milliseconds. So these were the two methods. The first one was just a brute force applying two loops, and second was the use of hash map. We solved this in time of O of n. So thank you for watching, and I see you in the next video.